150,000 Americans are living in the projected kill zone of a single volcano in Washington state, and the federal scientists who monitor it just publicly named the failure mode they fear most. They called it the thing that goes bump in the night. 3 Pierce County towns, Orting, Sumner, and Puyallup, are sitting in a corridor where the warning window between the start of the event and the arrival of a wall of mud is approximately 30 minutes. By the end of this video, you will understand exactly why Mount Rainier is now the most dangerous volcano in the United States, and why it does not need to erupt to do it. The United States Geological Survey put a number into the national news cycle yesterday afternoon that almost nobody in the Pacific Northwest has done the arithmetic on. 150,000 Americans are living in the projected kill zone of a single volcano in Washington state. 60,000 of them are living in the highest severity corridor, the one closest to the source, where the agency estimates the warning window between the start of the event and the wall of mud arriving at the edge of town is approximately 30 minutes. The volcano is Mount Rainier. It sits 60 miles from downtown Seattle. And the agency that monitors it has just publicly named the failure mode it is most afraid of in language that no federal scientific agency uses lightly. The geophysicist at the Cascades Volcano Observatory cited in the coverage is Andy Lockhart, who has spent his career studying these kinds of failures at this kind of volcano. And he called the mechanism, on the record, the thing that goes bump in the night. He gave the 3 Pierce County towns directly in the path a window of roughly 30 minutes between the moment the failure begins and the moment the wall arrives. The towns are Orting, Sumner, and Puyallup. The warning is structural. It is not a forecast of imminent eruption. It is the institutional system telling the country, in the most direct language it has used in 2 decades, that the gap between the engineering reality of this hazard and the public mental model of it has grown to a size that cannot be tolerated. A lahar is a fast-moving slurry of mud, broken rock, ice, snow, and entrained debris that travels down a volcano's river valleys at the velocity of a freight train. The word is Indonesian. It is the closest single term in any language to what the science is actually describing. The mixture behaves like wet concrete poured at speed. The leading edge can move at 30 to 40 miles per hour through narrow upper valleys. The flow depth in those narrow channels can exceed 100 feet. By the time it spreads into the lower-lying communities, it can still be tall enough to bury a 2-story house and dense enough that no swimming, no climbing, no structural reinforcement gets you through it. The only useful piece of information about a lahar is the direction it is coming from and how many minutes you have to be somewhere else. The no-notice category is the one that gives you the smallest answer to the second question. A no-notice lahar is a flow that begins without a precursor signal. The U.S. Geological Survey has built one of the most extensive volcano monitoring networks in the world around Mount Rainier, broadband seismometers across the cone, continuous GPS deformation stations on the flanks, infrasound arrays, satellite radar interferometry, gas chemistry monitoring, automated river valley sensors that trigger on ground vibration signatures consistent with sediment transport. The system is designed to detect precursor activity and warn the population before an event begins. The system works for the kind of volcanic failures most people have seen in documentaries. The no-notice category is the category where the system does not get the warning it was built to detect. The trigger event is small enough, or quick enough, or buried deep enough under the summit ice cap that the precursor signal does not exceed the threshold the agency considers actionable. The first definite indication that a flow is in progress arrives when the river valley sensors trigger downstream after the slurry is already moving. From that moment forward, the institutional system has 30 minutes to do everything. That is what makes Mount Rainier different from every other volcano in the standard public mental model. Mount St. Helens in 1980 gave the country 2 months of warning. The volcano started behaving differently in March. It produced a series of detectable earthquakes. It produced visible bulging on the north flank that scientists measured with theodolites. It produced small phreatic eruptions starting late March that the Forest Service was able to use as the basis for the red zone exclusion. By the time the catastrophic eruption happened on May 18th, the institutional system had done its job. 57 people died. Most of them were inside the exclusion zone in defiance of the evacuation order, or outside the zone in directions the precursor data had not anticipated. The system gave the population the chance to leave. That chance is what the public mental model has internalized for 40 years as the way volcanoes work. The Mount Rainier no-notice scenario is the agency telling the country that the way volcanoes work for this specific volcano may not include any chance at all. Mount Rainier is the unique node in the Cascade Arc where every multiplier compounds in the same direction. No other volcano in the lower 48 states has the combination of glacial ice volume, hydrothermal alteration depth, slope geometry, and downstream population density that Rainier has. The ice load is the largest concentration of glacial ice on any peak in the continental United States, with approximately 26 named glaciers, covering the upper flanks and total ice volume on the order of 4 to 5 cubic kilometers. A single cubic kilometer of glacial ice weighs around 900 million metric tons. Rainier carries multiple cubic kilometers of it, sitting on slopes of 30 to 40 degrees. The rock under that ice is the central problem. Over tens of thousands of years, acidic hydrothermal fluids percolating up from the volcanic system have chemically eaten the original crystalline structure of the summit rock and replaced it with low-strength clay minerals. The mountain that the upper kilometer of Mount Rainier used to be is gone. What is left in many places is a clay-rich body of altered material that has nowhere near the strength of the original rock. The acidic alteration is direct, observed, and measured. Drill cores, surface exposures, where ice has retreated, fumarole fields, where you can see and smell the altered rock with your own eye and nose, all confirm that the summit edifice is mechanically weakened to a degree that no other Cascade volcano matches. Combine the three ingredients: clay-weakened rock on 30 to 40 degree slopes with the largest ice load on any volcano in the lower 48 states pressing down on it, and a river system on the western flank that runs straight to the population centers in the lower valley. The mechanical system is loaded. The loading is continuous. At some point, on a timeline the agency cannot predict but can no longer call remote, a critical threshold will be crossed. The failure will not require an eruption. It will not require a major earthquake. It may not require anything observable at all from the surface. The collapse begins, the slurry forms, the flow enters the Puyallup River drainage, and the river channel delivers it to Orting in approximately 30 minutes. The mechanism, the U.S. Geological Survey ranks highest, is a sector collapse driven by progressive hydrothermal weakening alone. The clay rock holds together under gravity until it does not. The trigger can be a small swarm of micro-earthquakes that the regional seismic network records, but does not interpret as alarming. The trigger can be a pulse of meltwater that raises pore pressure inside the rock just enough to cross the failure threshold. The trigger can be gradual creep that has been building for years and finally produces a discrete slip. None of these triggers needs to exceed background noise. The failure happens. The institutional system finds out about it from the downstream sensors. The clock starts at that moment. If the no-notice mechanism sounds like a theoretical worry, the geological record under modern Tacoma, Auburn, Kent, and Enumclaw will tell you it is not. 5,600 years ago, the entire eastern summit of Mount Rainier collapsed. The event is called the Osceola Mudflow. It is the largest known lahar in the history of the Cascade Range. It mobilized between 3 and 4 cubic kilometers of altered volcanic rock, the same kind of clay-altered rock that is sitting under the summit ice cap today. The flow traveled approximately 220 miles to the Puget Sound. It buried 100 square miles of the lower lowland under deposits up to 100 feet thick. It changed the geography of the entire region. The volume figure cited in yesterday's coverage, the comparison to 1.5 million Olympic-sized swimming pools, is the public translation of that volume estimate. The Osceola deposit is not abstractly ancient. It is recent on the geological timescale that volcanoes operate on. The volcano has not substantively changed in 5,600 years. The rock chemistry is the same. The ice load is the same. The slope geometry is the same. The river drainages are the same. The cities of Tacoma, Auburn, Kent, and Enumclaw sit directly on top of the Osceola deposit at depths that vary from a few feet to 100 feet below the modern surface. When the city of Tacoma builds a new structure on the lower industrial flats, the geotechnical engineers identify the lahar deposit in the soil profile. When Auburn permits a new subdivision, the same identification happens. The deposit is mapped. The deposit is known. The deposit is the literal foundation that the modern metropolitan region has been built on. The more recent and more directly relevant event is the electron mudflow, dated to approximately 500 years ago. The electron failure originated from the western flank, the same flank the US. Geological Survey has flagged as the highest priority surveillance target today. The flow traveled down the Puyallup River drainage. It buried what is now Orting under approximately 20 feet of cemented mud. The mean recurrence interval for events of comparable size at this volcano is approximately 500 years. The electron mudflow itself happened approximately 500 years ago. The clock has been running. The clock is now at or past the mean. This is the statistical fact the agency has stopped describing in the language of probability tables and started describing in the language ordinary people use. The clock has run. Every house in Orting today is sitting on the cemented surface of the previous electron mudflow. The school the children walked out of in the April 2025 evacuation drill is sitting on the previous electron mudflow. The roads they walked along are sitting on the previous electron mudflow. The recurrence interval is not a theoretical statistic. It is preserved in the ground under your feet if you happen to be standing in Orting reading this. The mountain has demonstrated, in the geological record we can dig up and verify, that this is where it sends its flows. The hazard map the US Geological Survey publishes is the historical record of where the previous flows went, plotted onto the current map of where the current people live. The corridor is already chosen. In April of 2025, 45,000 students and staff from more than 20 Pierce County schools participated in the largest lahar evacuation drill ever conducted in the United States. The drill was coordinated by the Pierce County Department of Emergency Management, the U.S. Geological Survey, and the local fire and police agencies. The drill simulated the arrival of a Case 1 lahar at the upstream sensors on the Puyallup and Carbon rivers. The simulated alert chain was activated. The outdoor warning sirens in Orting and the other affected communities sounded for the full duration of the test. The schools in the inundation zone activated their pre-rehearsed evacuation protocols. Teachers led their students out of the buildings on foot, walking along the routes the U.S. Geological Survey had identified as the highest probability routes to high ground above the projected inundation line. The students walked. They were not allowed to drive. The drill was timed. The fastest groups made it in around 40 minutes. The slowest did not finish the route. The drill was conducted in spring, in good weather, with clear paths, no traffic, and the children moving as a coordinated group under teacher supervision. Under realistic conditions, winter weather, families trying to find their children, traffic clogging the limited road network, the natural human delay between hearing the siren and beginning to move the times would be longer. The U.S. Geological Survey has spent years modeling those longer times. The honest conclusion the agency has reached is that for a significant fraction of the population in the Case 1 zone, the threshold sits above the time the lahar would take to arrive. Orting is the centerpiece of the institutional concern. The town sits in the lower Puyallup Valley about 23 river miles from the summit. It is built directly on the electron mudflow deposit. The population is approximately 9,500 residents. The community is growing, with new townhouse and apartment density on the available flat land of the valley floor. The road network is limited. State Route 162 is the single major arterial out of the valley to the southeast. It is a two-lane road. In a real evacuation scenario, it would clog with traffic within minutes. The town has built 2 pedestrian bridges over the Puyallup River, specifically to provide foot evacuation routes for the schools, because the school district concluded that walking children out of the inundation zone over a dedicated pedestrian route was a more reliable option than expecting cars to navigate State Route 162 in the middle of a panic. The roof of Orting High School is engineered as a vertical refuge for the alternate scenario where ground evacuation is not possible. The school district maintains a permanent lahar drill protocol that every teacher and every child rehearses multiple times per year. The protocol is not optional. The protocol is not a fire drill. The protocol uses the word lahar directly because the district concluded that obscuring the language would not produce the muscle memory the children actually need. Sumner and Puyallup are further downstream and would receive somewhat more warning time, on the order of 45 to 60 minutes for the leading edge of a typical Case 1 event. They also have more developed road networks. They have larger populations. Puyallup has approximately 40,000 residents. Sumner, about 10,000. The total Case 1 zone population, summed across all three communities and the surrounding unincorporated areas, reaches the 60,000 figure cited in yesterday's coverage. The broader Case 2 and Case 3 zones, which would be reached by a flow on the upper end of the size distribution, raise the total exposed population to the 150,000 figure that the agency put into the national headline cycle. Most viewers will hold Mount St. Helens as their mental model for the worst U.S. volcanic disaster. The May 18th, 1980 eruption killed 57 people, destroyed more than 200 homes, took out 195 miles of road, and removed 27 bridges. The lahars in the Tautla, Cowlitz, and Columbia drainages are the proximate flow physics analog for what a Mount Rainier event would look like downstream. The flow velocities, the entrainment dynamics, the depositional aftermath, all of it transfers directly. What does not transfer is the warning window. St. Helens gave the country 2 months. Rainier, in the dominant hazard mode the agency is now publicly worried about, would give the country 0. The international analog, the U.S. Geological Survey scientists keep returning to, is Nevado del Ruiz in Colombia, November 13th, 1985. A relatively small lahar from a partially monitored volcano killed approximately 23,000 people in the town of Armero in a single night. The volcano had been producing precursor seismicity for months. The Colombian government had commissioned a hazard map. The international scientific community had visited the volcano and produced explicit warnings. The local newspaper had run articles describing the threat. When the volcano produced a relatively small eruption that melted the summit ice cap and initiated lahars in the Lagunilla River system, the warning chain failed. The seismic detection occurred. The institutional alert was issued. The alert did not reach the town in time. The lahar arrived in the middle of the night at approximately 30 miles per hour. Most of the population was asleep. Most of the deaths occurred in the first 10 minutes. Andy Lockhart was part of the U.S. Geological Survey response team that arrived in Armero in the aftermath. The integrated lahar warning system in place at Mount Rainier today was built in significant part by the people who saw firsthand what happened when the warning system at Armero did not work. The Armero lesson is the operational template the entire international lahar community has been working off of for 40 years. The institutional system is necessary, but not sufficient. The warning has to reach the people in the path. The people in the path have to know what the warning means before they hear it. The evacuation has to be rehearsed before the event, not improvised during it. Pierce County has built much of this infrastructure. The U.S. Geological Survey has spent decades helping. The system at Mount Rainier today is, by any honest international comparison, one of the best lahar response systems in the world. It is still, by the agency's own admission, not certain to be sufficient. The 30-minute window is the structural limit of what any institutional system can accomplish from a no-notice trigger. The agency has not raised the alert level at Mount Rainier. The seismic background under the volcano is within historical norms. There is no current precursor activity that would indicate an imminent event. What changed yesterday is not the volcano. What changed yesterday is the language the institutional system is using to communicate the structural reality of the hazard. The phrase no-notice lahar is now in the national headline cycle. The phrase, the thing that goes bump in the night, is on the record from a federal scientific agency. The April 2025 drill, the 45,000 students, the 20 schools, the engineered school roof, the pedestrian bridges, the State Route 162 single arterial problem, all of it is part of an institutional posture shift that has been underway for years and has now reached the point where the agency is willing to put the operational reality directly into the national conversation. If you live in any of the named communities, the U.S. Geological Survey lahar hazard maps are public. The Pierce County Department of Emergency Management publishes them. Look up your address. Find the nearest high ground above the projected inundation line. Drive the route, then time the walk. In a real event, the roads will clog within minutes, and the walk is what your family will actually do. Sign up for the Pierce County Alert System. The siren is the trigger. The phone notification is the confirmation. The walk to high ground is the survival. 30 minutes is the budget. The agency is going to keep monitoring the volcano. The Cascades Volcano Observatory operates around the clock. The River Valley sensors are live. The institutional system has done what the institutional system can do. The mountain is loaded. The mountain has been loaded for thousands of years. The mountain will release when the mountain releases. And the only thing that will be different on the morning after the release is the number of people who knew the route, who had walked it, who had signed up for the alert, who had taken yesterday's news cycle seriously enough to translate it into the small, specific actions that turn a warning into survival. We will keep tracking this. The signal worth watching is not the seismicity at the volcano. It is whether the public update is finally going to catch up with the engineering reality.